Alright, so I thought we would walk through an example of finding a fractional dimensionality, or any sort of dimensionality, using vectors in the first place. So there's units attached to our numbers. They're not just numbers. Okay. So here we have our three variables, right? So n is the number of units used. I changed it from epsilon to f because that makes more sense to me. F is your scaling factor. And d is the thing we're looking for. It is the number of dimensions of our figure. So for a Koch snowflake, n is 4, while your scaling factor is 1/3, and your dimensionality is like 1.26 something. Okay. Now, what is happening here? So here I just used natural logarithms. It doesn't matter if these are just numbers, right? If these are literally just the scalar number and the scalar scaling factor. This will be a scalar number of dimensions. Then we like logarithms as you normally think of them, where the base is a scalar number. That's what's forcing this, right? Because you can't take a log base scalar number of a vector. That's where it doesn't make sense. That's where it fails. And that's where I'm saying, well, are we just stupid? Because obviously you can't do that, right? Because if look. I'll show it again, right? So say we have a to the third. That's 1 times a times a times a, right? This 3 is the output of the logarithm function, right? If this is a vector with a unit on it, then you're going to get the cube of that unit as a result, as the unit of this guy, right? So this is the thing you take the logarithm of in this base to get 3, right? So let's call this b, right? So this is where we get log base a of b equals 3, right? That's where all these numbers are coming from. The unit on b will be the cube of the unit on a. If your base is just a scalar, then you have to take, when you take a logarithm with that base, you can only accept scalars as your argument, right? And this is where what it was saying in the Wikipedia article about transcendental functions and dimensional analysis, this is what they're talking about. They're just saying it very incompetently and don't seem to understand what's actually happening. Okay, so if instead what we do is we take, instead of doing just like this, random log base some scalar number, what if we do something like this, where we are taking, so this is really the same thing, right? This is the negative some sort of log of n over some sort of log of f. It's the same as this up here. But what I'm doing is I am taking log base f of n and f. Okay? And now f can have a unit included on it. Alright, so if I copy this, let's see. If I think this through a little better. This has to be scalar, this has to be scalar, and this is for There you go. So the arguments of these logarithms must be scalar because the base is scalar. But here, let's see. This is going to be... There you go. Now n is a vector whose magnitude is the number of units used. F is a vector whose magnitude is the scaling factor. And dimensionality is still scalar, right? Log output's a scalar naturally. Because dimensions don't have dimension. A number of dimensions. I mean, it does, sort of. Meh. We'll just skip over that. We'll just treat it as a scalar. Yeah, so something nice happens here, right? Because log base something of that thing is just 1. So this term disappears. And now we're just looking at the negative log base f of n, which is far simpler, right? So yeah. So now your units will come out, right? And what we can see is that, you know, say your units on this is a meter, right? So if we're measuring the Koch snowflake with meters, we get D is 1.26 yada yada. I think the next digit was a 1. I don't recall. I don't give a shit. Meters. Well, right. The dimensionality is that, but so this is the exponent on meters, right? So the unit of the snowflake, there we go, is meters to the 1.26 yada yada, right? So it's not meters squared, it's this fractional exponent on the meters. That's what it is, right? That's what you measure a Koch snowflake in. And, you know, this is very similar to, like, right, so, like, speed is position over time. Acceleration is position over time squared, right? This is part of the dimensionality of this, right? So this would be like meters per second, while this is just meters per second. That's very much what's happening here. It's just not an integer. This shouldn't be a problem. This shouldn't be a mindfuck for you. Like, maybe a tiny bit, because what does that really mean? But I can show you what that means, because I can show you what a Koch snowflake looks like. Right? Like, this shouldn't be this much of a mindfuck. This is normal. Right? Acceleration has a different unit from speed because of the exponent on your dt term. Well, it's not really a term. Yeah, but because of the exponent on dt, right? That renders it a different unit. So logarithms here, telling us what the dimensionality is, plays directly into dimensional analysis. What the fuck is happening? I don't understand the problem. Like, the claim that you can't use transcendental operations, transcendental functions, with respect to dimensional analysis is just wrong. As I've said in several videos now, it's just stupid and wrong. What the fuck are we doing? Jesus.